So now in this lesson, we are introducing the law of sines and law of cosines. So going back to like our trig ratios, we could find sine. So in order, like let's say when we were working with our right triangles, right? And we're given an angle, you're given like theta, you're given a side, let's say is 7, and you're looking for another side, right? We could use our trig ratios. So depending on the information, we could use our sine, cosine, or tangent to find the missing side length or a missing angle, right, for inverse trig. But in this case, to find the missing side length, right, or to find the missing angle, we had to have a right triangle. So now with the law of sine and law of cosine, what if you have what's called an oblique triangle? Like here is triangle ABC. This is not a right triangle. Notice how you are not given a right angle. So can we use our trig functions? Can we find sine, cosine, or tangent in using those ratios? No, because it's not a right triangle. So in this case today, we are going to introduce the idea of the law of sines, where you're going to use the law of sines with an oblique triangle here to find a missing side length or to find a missing angle without a 90-degree. So the law of sine is basically here that we've got our ratios where the opposites create the ratio. So angle A and side A are a ratio. So A to sine of angle A. Now that is equal to our other ratios. So angle B is opposite side B. So notice here, if we have our side length up top, then we have our side length up top. So sine of angle B. Or what if you're given C, right? So same thing, angle C opposite from side C. So these are the ratios. Now, could you also write this where the angles are up top? Absolutely. So you could also follow the law of sines where you have sine of A, sine of B, and sine of C up top, your ratio, right? But that means it's still the case of whatever side is opposite of the angle. So lowercase a, lowercase b, lowercase c to represent the side lengths. So here, when we get to some mathematical without pictures, keep in mind, the uppercase represents the angles and the lowercase represents the sides. So like here, for example, I'm looking for side XY. So I'll put my X here, right? Because that's what we're solving for. Now notice we are not given a right triangle. So here I do notice though how 15 is opposite from the angle 36, right? Angle Y and angle Y here. And notice how here angle 16 from angle Z. So you know what? I'll go ahead and label this like what we were talking about with a lowercase z. Because notice how 116, this angle is opposite from the side that we're looking for. So we are going to set this up as the side length, which is 15, 2. So what is our sine here? So sine of what is opposite from 15? 36. Then that is equal to, we are looking for the side. So I'll put Z and then sine of what angle is opposite? 116. So now notice we just have like our proportion. Now we just cross multiply and solve. So we are going to multiply 15 times sine of 116 degrees. That is equal to sine of 36 degrees times z. So notice in the end here, if we're solving for z, but it's being multiplied by sine of 36, what do we have to do to get it by itself? Divide by sine of 36 degrees. And that is how we're going to solve. Notice in the end how it's a proportion, cross multiply and solving for your variable. So here you put this in your calculator, 15 times sine of 116 degrees divided by sine of 36, and z is going to be approximately 22.9. Make sure your calculator is in degree mode. So here we go. We are now going to look for HK. Well, HK is opposite from which angle? P. So notice how HK is opposite from P. So I'll pull it lowercase p. Now notice we're given 23. 23 is opposite from which angle? K. Well, do we know what K is? No. Can we figure out what K is? Yes, because we are given two angles. So now notice, can we find the third? Absolutely. Subtract from 180. So this angle is 105 degrees because the three angles add up to 180. Now we can set this up. So again, side length of 23 is given to us. So 23 over sine of what was opposite? 105. So notice how this is opposite of K. So sine of 105 degrees. That is equal to our lowercase p, because that's what we're solving for. HK is opposite of which angle? Angle P, 36 degrees. So notice how here we didn't need to solve the 39, but we did need it to find that third angle. And here we go. Cross multiply, 23 times sine of 36 degrees. That is equal to P times sine of 105 degrees. Then what do we do here to solve for P? Well, if it's being multiplied by sine of 105, then divide by sine of 105 degrees. So now practice putting that in the calculator, right? Making sure you're in degree mode. And P is approximately 14. So here, 1C. Go ahead, let's see. How do you think you would set this up? Notice how we're solving for PQ. So identify what its opposite and if we have that information. So what is side PQ opposite of? Angle R, right? Angle R. So we're going to label this lowercase r. Now, what is the 23 opposite of? Angle Q, right? The 35 degrees. So lowercase q. So we can go through now and set up. So here we've got 23 to sine of, what is it opposite of? 35 degrees. That is equal to, now we're going to solve for r, then sine of, what is it opposite of? 87 degrees. Then again, cross multiply, right? 23 times sine of 87 degrees. That is equal to r times sine of 35 degrees. Now notice you are multiplying again r by sine of 35. So now what do? Divide by sine of 35 degrees. And so here you end up with r is approximately, if you need to pause so that you practice putting this in the calculator, you should get approximately 40. So what do you notice about right now these situations in order to use law of sine? Because eventually we're going to use law of cosine. Well, you should notice here to find a sine length, you're given two angles and a side. Two angles and a side. Two angles and a side. So notice how here we had AS. Here we had ASA. And here we have AAS. So again, notice two angles and a side, we can use law of sine. So go ahead and pause the video now and do these two U-tries on your own. And here we go. So here you should have noticed that 34 was opposite from angle C. So this is lowercase c, which means you needed to find this angle to set up your ratio, which here, subtracting from 180, is 58 degrees. Then you are looking for side AC, which is here, which was opposite from angle B. So you are looking for lowercase b in this case. So to set up now, we're not going to even use the 87 degrees. So here you've got side 34 is opposite of sine of 58 degrees. That is equal to B, which was opposite of B, so sine of 35 degrees. Then cross multiply and divide, and you end up with B is approximately 23. Then here 1B, even though it's a word problem, this was nice as well because the picture was also set up for you. But again, 10 was given to you opposite from the fire. So you needed to figure out here at the location, that is 74 degrees. And you are solving for lowercase b because that was opposite from station B here. So here to set this up, you have 10 miles to sine of 74 degrees because that was opposite is equal to B over sine of 64 degrees because again, that is the angle that is opposite. Cross multiply and solve and you get B is approximately 9.4 miles. So now what if you're looking for an angle measure? So think about just like the trig ratios, right? When we were looking for an angle measure, we always did the inverse sine or inverse cosine or inverse tangent. Well, now because we don't have right triangles and we're using the law of sine, we're going to, in the end, use inverse sine to find the missing angle measure. Still the same setup, right? So like here, we're looking for angle S. So here's angle S. So what is opposite from angle S? The 23. So this is lowercase s. What does the 42 represent? It is opposite from angle T. So lowercase t. So notice how here we can go through and start solving. So we're going to set this up. So side 42 is opposite of sine of 114 degrees. Then that is equal to, now we do have our other side, so 23 is opposite of sine of S. So same thing, we're going to still cross multiply. So I've got 42 times sine of S. That is equal to 23 times sine of 114 degrees. So now here we're solving for S, right? The angle. Well, right now it's being multiplied by 42. So we're going to divide by 42. Now you could go ahead and put this in the calculator, right? And get your decimal. So now notice, but for time, I'm going to go ahead and show you so you can put this all in the calculator together. You've got sine of S now, right? Because we divided by 42 is equal to this fraction, 23 times sine of 114 degrees over 42. So now notice, how do we get rid of this sign here? That's why now we're going to find inverse sine. So here now you've got the inverse sine of, then put this fraction in your calculator. 23 times sine of 114 degrees, divided all of that by 42. And you should get that angle S is approximately 30 degrees. Now, let's say this is a little tricky for you, then that's fine. Go ahead and put this fraction in the calculator first, right? Then you press and get to sine, the inverse sine, which is you press the second button on your calculator and sine, right? So you press those two buttons. Then once you've got this decimal, right, then you get to your answer button on your calculator as well. So you can find the angle measure, which is approximately 30 degrees. So you've got the options. So here we go. Let's go to the second one. I'm finding angle T. So here is angle T. It is opposite from 6. So here's our lowercase t. Now, 16 is opposite from 88 degrees, which is our r. So lowercase r. So again, we have our information, and here we go. So we've got 16 is opposite of sine of 88 degrees. R and R. That is equal to, here we've got sine or 6 over sine of t. Same thing again, right? Cross multiply. So this is 16 times sine of t. That is equal to 6 times sine of 88 degrees. So now here we're solving for the angle t being multiplied by 16. So we're going to divide by 16. So then here now we've got sine and take the inverse sine of our fraction here. Or again, get the decimal and take inverse sine of that decimal. You get, practicing putting in the calculator, that angle T is approximately 22 degrees. Let's do this last one here. So angle A. We're looking for angle A. So what's opposite from angle A? 19 centimeters. So what does the 28 centimeters represent? It's opposite of 75 degrees angle B. So we're going to put lowercase b. Here we go. So now I've got 28 over sine of 75 degrees, right? So we put the opposites together. That is equal to, put your side up top, so 19 over sine of A. And here we go, cross multiply, right? 28 times sine of A. That is equal to 19 times sine of 75 degrees. So how do we solve? What do we do first? Divide, right? By 28. If it's being multiplied, divide by 28. Now we've got sine of A, take inverse sine. And here you get angle A is approximately, so again, if you need to pause, you practice putting this in the calculator, and you should get 41 degrees. So go ahead and pause the video now and try these two U-tries, getting the angle on your own. And here we go. So you try 2. Now, you should have noticed you could have actually solved this a couple of different ways because you were given a right triangle. So if you're looking for angle A, which is here, and you're given the opposite of the angle and the hypotenuse. So what is opposite and hypotenuse? Well, it just so happened that this was sine. So you could have used sine of A is equal to opposite, which is 28 over 41, and then find the inverse sine of this fraction, this ratio here. So you end up with angle A is equal to, so you were able to use trig ratio. So here, let's still use our law of sine. So you're looking for angle A. Well, what's opposite? The 28. Then what's opposite from the angle B? The 90 degrees. The 41. That's your lowercase b. So here we go. You could have set this up as 41 over sine of 90 degrees. That is equal to 28 over sine of A. When you cross multiply and solve, remember that last step, right, is the inverse sine. You should have gotten the measure of angle A is approximately 43.1 degrees. And if you also notice, you could have used a trig ratio, you should have gotten the same answer. So now angle B. Here's angle B. So that's what you're solving for, which is opposite of 4. Then notice angle 69 degrees. Angle C is opposite from 18. So here I've got 18 over sine of 69 degrees. That is equal to, 4 over sine of B. So again, cross multiply and solve. You should get, after taking inverse sine, right, because we're looking for an angle measure, that angle B is approximately 12 degrees.